Today we'll talk about the last part, chapter 9. It's about application to integration. As you all know, last time we did definite integrals. And definite integrals simply is where you take any function you wish, integrate with respect to x from a lower value of x1 to an upper limit of x2. This time we're going to call it area. So, we have not learned how to use definite unless for a reason. Why do we use it? There are many applications. One of the applications is called area. You have volume of revolution, you have moment of inertia, you have speed, you have acceleration. All these are applications to engineering. Let me start with an example. Example number 1. I have a function called f of x, which is 3x squared plus 2. All right? That function there is an area bounded between this function and the x-axis. Now, where is the area? All the way until here. It's not bounded yet, but we can bound it if I take it between, for example, an upper limit of 4 all the way down to a lower limit of x1 equals 1. So now I am having an area that is surrounded by 4 sides. One of them x equal 1, x equal 4, y equals this, and x-axis. How can I find this area? How can I find the exact answer? It's impossible to find the area by using another technique. It's not a square, it's not a triangle, it's not a half circle. Okay, so let's apply that rule. Area equals the integration from 1 to 4. And the function I have 3x squared plus 2. And I'm going to integrate this with respect to x. So what is integration of 3x squared? 3x cubed over 3 plus 2x from 1 to 4. You may cancel this one out. So if you're going to plug the 4 cubed is 64 over plus 4 times 2 is an 8. All right? Plus, minus 1 cubed is 1, plus 2 is a 3. So, 3 minus 61, and the answer is exactly 69 units squared. If you used the integration symbol that we talked about, that you have in your calculator, remember the integration symbol? Just put that one here. Put the limit 1, put the limit here 4, make sure it's between the bracket, and you press, and you get that one. But that's only to check. All right? So you will be given an assignment this weekend. All right? By Thursday or by Friday, whatever, because we have 2 classes for each section. You can use this to check, but you have to show me the working out. And be careful. We are so picky on details. All right? That was the first example. Let's take another example. Let's change the subject into a trigonometric function. How this is called sine function. It has a period of pi, and half of it is 2 pi. Half of the half, pi over 4, and 2 pi plus 1 pi, 3 pi. Halfway is 3 pi over 2. What am I looking for? Am I looking for the area bounded between the x-axis, which is that, and the curve whose function is sine 2x. You can write y all of x. Could be all, but and this spine. So this area is bounded between x-axis, the curve, and this is called in English x equals 3 pi over 2. There's no need to talk about that because it's already a 0. It's like x-intercept. Okay? What can I do in this case? So remember, what we do is a direct application on definite integrals. So no need for that. خلاص. That was a title. You already got it at the beginning of the video. So the area is, the function is sine 2x dx from pi over 2 all the way up to 3 pi over 2. 3 pi, yeah. All right, so far so good. I think halfway is 3 pi over 4. Why? Because 2 pi plus 1 pi, all right? I just want to, no, actually there's something wrong here. It's not 3 pi. Why don't we just make it simple? Find the whole area, because I want to get somewhere. So let's say, and why this is 2 pi? No, this is pi. So this is called pi. This is pi over 2. I'm very sorry. And this is pi over 2 is a 4. Okay, so 1 plus half, 1 and a half, which is 3 over 2 pi. So, okay, this plus that is divided by 2 is 3 pi over 4. So that point, sorry, clear, 3 pi over 4. All right, now I can get my numbers right. Either I find the whole area or I can find half of it. So why don't we just find half of it? Just for the sake of getting somewhere. I'm having something in mind. I don't care about finding this. Okay, let me just find half of it. So my limits is correct. From pi over 2 until 3 pi over what? Until 3 pi over 4. Okay guys? Clear? So the whole period is pi. Half of it, pi over 2. Half of the half is pi over 4. So quarter and a quarter, half. Half plus another quarter, 3/4. Plus another quarter is 1, which is I'm okay. All right, so what is integration of sine 2x? Minus cosine 2x. And divided by what? From pi over 2 until 3 pi over 4. Why don't we get the minus half out of the way? Like this. Minus half cosine 2x from pi over 2 to 3 pi over 4. What is the usual method? Let's substitute the higher. Leave this one out. 3 pi over 4 times 2. Look, 3 pi over 4. We substitute for the x. Times it by 2. It's 3 pi over 2. So what's cosine? 3 pi over 2. We'll do it in a minute. Minus, plug this one there. 2 times pi over 2. So cosine pi. Okay? I try to use a calculator, but I don't need it. What's the cosine 3 pi over 2? 3 pi, 1.5. What does it mean 1.5? It is somewhere here. Here. And this is 0 minus 1. So the cosine is 0. So the answer for this, you can use your calculator, so don't feel bad. And what is cosine pi? Minus 1. Times it by what? So 0 negative 1 is 1. 1 times half. The answer is minus half unit squared. Can an area be negative? No. Negative means that you are below the x-axis. That's all. As an indicator that you are below. But the real answer will be, you got to take the absolute value. Therefore, the area is a half unit squared. You can never say area is half. All right? So that's the idea here. So by the way, if this is half and this is half, this is 1. Half and half 1. So what's the total area in case I want to ask something silly like this? This is 1, this is 1. The total area, what is it? You will say this is 1 minus 1, right? Yes, true. Under the curve minus 1, above the curve is 1. But because area cannot be negative, so it's 1. 1 plus 1, total area is 2. That's if the question was asking for finding the whole thing. So it's a little nice to use common sense. All right, guys? Let's look at another example. Very interesting topic, very simple, straightforward, but mistakes can be a lot if you don't pay attention to details. Number 3, I'm going to give you a simple function. You've already heard about it. And this function is called x cubed minus x squared minus 8x. That's a cubic function. And that's your y-axis, that's your 0, that's your x-axis. The point of intersection is a 4, 0, and what is it here? It's a negative 2. I could simply ask you, find the area bounded between the curve and the x-axis. It would be all of this and this. But I can simply say, from x equals minus 1, all the way until x equals 3. So the question is simply, find the bounded area. Find bounded area between f of x and the x-axis. From x equals negative 1 to x equals 3. This is the area you're looking for. From x equals 1, minus 1, all the way until x equals 3. So how may I find this area? Okay. To do that, we know that the rule of the area is what? Listen carefully. You have one up, one down. We have to break this into two integrals. The first integral, who comes from negative 1 to 0. That's the first integral. What is the function? Is the same. X cubed minus 2x squared plus minus 8x. I can call this area 1. There is also another area here. I can call this area 2 if you wish. Area 1, area 2, I just found, or I will be looking for area 1. Now area 2, it's all the way from 0 until 3. And you know the answer is going to be negative. And you know you're going to take its modulus to make it positive. So what is the function? X cubed minus 2x squared minus 8x. Do each one separately and then add them up at the end, all the way until the end. So what is the integration of x cubed? x4 over 4 minus 2x cubed over 3 minus 8x squared over 2 from negative 1 to 0. I would not mind if you take this one and go to your calculator, because you're going to find the answer 37 over 12. Unit squared. I will allow you in the exam, if you got to this level, you can use your button in the integration. Likewise here. What is the integration of this? It's an x4 over 4 minus 2x cubed over 3 minus 8x squared over 2. But the limits are different. It's from 0 until 3. I will also allow you, and guess what? The answer should be negative. Don't even think about it. The calculator will give you negative. All right? And it's going to be negative 135 over 4. Unit squared. Why is negative? because it's under. Now, finally, remember something very important. You cannot accept an answer being negative. So you have to say it's 135/4. Now you have two answers. You have the positive answer, because area can always be positive, and that one. So what's your job now? To do the last step. Total area equals area 1 plus area 2. Since area 1 is 37/12, area 2 135/4, I did my homework and the answer is about 36.83 unit squared. So as far as you are having one area up, one area down, do them separately. Don't mix it. Don't say from -1 to 3. You can't. Even software cannot give it for you, because you will get a negative. And then when you have positive and negative, you have the answer. But make sure the area here to be turned into positive. Who will decide that? You have to make the change. A calculator doesn't do for you. You have to think, how can I do it? All right? That's example number 3. Let's have one more example, and then we will relax. And inshallah tomorrow, I'll make you another video. All right? These examples are all in your worksheet. I just changed some numbers, so I'll give you a chance to do more on your own. Let's look at example number 4. I'm going to give you a function whose equation as before all right, and another line, straight line, whose equation is what? G of x was equal to x7 minus x. Seven minus means that's 7. fx1 plus 1 means this is 1, for your extra information. So what's the question we're looking for? Obviously, I'm looking for the area bounded, surrounded between the curve and the straight line. Keeping in mind, this is your x-axis, that's your y-axis. So gentlemen, we have a problem here. How can I find this point of intersection? That comes math 1. To find that point of intersection, you've got to equate those and solve them simultaneously. And you know what simultaneously means. So, x squared, bring the x, plus 1 minus 7, all of that must equal to 0. And then, x squared plus x minus 6. I'm not going to factorize it for you because I know you don't like it, but for the sake of revision, what times what give me 6? 3 and 2. The difference between them is 1. The plus goes to the bigger number. So you have two possible values, minus 3 and 2. That's your negative 2. Sorry, the 2. And that's your negative 3. So, your limits to find the area which is bounded between two curves is from negative 3 to 2. Sometimes it's your job to find that, and you will see that. Always our quizzes, exams comes with you have to find the limit, so you get to know this. So make sure that you should be able to solve this simultaneously, since both have the same y. Now, the trick is here. If you notice something, this area from here to here is all of that. While this area under this curve is this. So if I'm looking for that little blacky one, You've got to take the big area under the straight line minus the less area under the red one. If you don't get that, well, there's another way. The top line equation minus the one below equation. And then go ahead and simplify that. So 7 minus x squared minus 1, like this. 7 minus x 7 minus 1, I think is a 6, minus x squared. The integration of 6 is a 6x, of x is an x squared over 2, and the x is x cubed over 3. And where is that from? From -3 all the way to 2. See how much work you have to put in all of that? Now, at the last step, you should be able to do the only thing that you should know. You can use a calculator. If you don't like it, it's up to you. You're going to plug the 2 first. That one first. Then you're going to substitute this. 6 times minus 3. Minus 3 squared over 2. Minus 3 cubed over 3. Look how hectic is that. Yes, you can do that by calculator. Well, I did my job. I did what? I went to my calculator. I used this. From -3 to 2. I put this in my calculator, even though I got up to here. So now you have 2 options. Either do it manually, or use your calculator, and the answer is going to be 125 over 6 units squared. So, make sure you find the points of intersection. Put them on the graph. You need a sketch in front of you. Apply the rule. Don't mix them up, because the one who has bigger area under it comes first. All right? The one has less area comes, because the big area and the small area will give me that thing. Put the limits. Okay? Don't say from -3 to 0. If you do that, you're wasting your time, because all the area is continuous. Unless one is like this, for example, and one is like that. Yes, you've got to say -3 to 0, 0 to 2. But it's not like this. It's the whole area above the graph. You're lucky. And then make sure you simplify the bracket properly. -6 and 7 minus 1 is this much. 7 minus 1 is a 6. Once you get here, you must show me how to integrate, because each one will count a few marks. If you don't have the setup, it means you don't understand. Now we have an option. 2 options actually. Either you finish this on your own. You are at home assignment, you can do that. Show me the substitution and then use a calculator. Or go from here right away, but use your calculator. With what you use the integration symbol. Just put that one, limit, okay? You got -3 here, you got the 2, you've got this one. Here, equal, we'll give you that. But you must show me the integration. You can't jump from here to here, you lose half of the mark. All right? Let's call this area video 1, about areas. They are more sophisticated areas, very advanced. We don't want that. So what we did today, we found the area under the curve. We use once the normal values, and we use then the radian in the sign. Then we have 2 areas, one up, one down. Make sure they are both positive when you add them up. Then I just found here area between 2 curves, or between 2 graphs. You can have an area between 3 graphs. You can have an area between 4 graphs if I wish. You just have to go step by step. So thank you very much for today. That will be the first video about it. Look at it carefully. Enjoy yourself.